examples for sequence. The first one is, if I consider a sequence an equal to 1 by 2 power n. Always remember n always raised from 1 onwards. That means 1, 2, 3 and so on, natural numbers only. So what is the sequence? 1 by 2, 1 by 2 square, 1 by 2 cube and so on up to infinity. If I write another one, an equal to minus 1 whole to the power of n. Minus 1 whole to the power of n. Is it visible?
Yes, sir.
Yeah. An equal to minus 1 whole to the power of n. If I take n equal to 1, the value is negative 1. N equal to 1, n equal to 2, the value is positive. Next 3, negative 1,
Negative.
positive 1 and so on. Okay, so this is a set minus 1 comma plus 1. This is called set. And what is this is called? Minus 1 plus 1 minus 1 plus 1 infinitely many times.
Sequence.
It is called multi-set. This is called multi-set. And this is simply called set. Okay. And third example, an equal to, if I write minus 1 whole to the power of n into n. Into n. So when n equal to 1, this is minus 1. When n equal to 2, plus 2. When n equal to 3, n equal to 4, 5 and so on, like this. Yes, these are the examples for sequence. Why I'm giving these examples, let us see. Now, the properties of sequence. The properties of sequence. What is the main properties? First one, bounded above sequence. Bounded above sequence. Bounded above sequence definition is a sequence, I will write SEQ for sequence. A sequence AN is said to be bounded above. Is said to be bounded above if there exists a constant. If there exists a constant, this may be positive constant or negative constant, whatever it is. If there exists a constant capital M such that an is less than or equal to m, this is true for all n. Am is less than or equal to n for all n. This is called bounded above sequence. What is this meaning? Sequence an is said to be bounded above. Means, see, this is for all n means, that is, the a1 is less than or equal to m, a2 is less than or equal to m, and so on, like that, up to infinite. That means every term in the sequence must be less than or equal to m. That means, let me consider one example. This example, if I take an equal to, let me consider 1 by n. Simple sequence, 1 by n. So what is the sequence? 1, 1 over 2, 1 over 3, and so on. Right? Now, tell me, 1 is less than or equal to what? 1 by 2 is less than or equal to what? 1 by 3 is less than or equal to what? What is this value?
1.
1.
Yes?
Any number.
Yeah, what
Any
that
natural
number?
number. Natural
Any
number.
natural number. Yeah, exactly.
Not-
What is that? This may be 1, right? 1 less than or equal to 1 is true. 1 by 2 less than or equal to 1. 1 by 3 less than or equal to 1 and so on. Or, all of you, one more point. 1 is less than or equal to 2. 1 by, not only 2, maybe 1.1, right?
Any real number
1 by
greater
2
than
less than or equal to 1.1. 1 by 3 less than or equal to 1.1. Or this may be 1.2. That means whatever the value greater than 1, all elements are less than or equal to that value, correct?
Yes.
Please don't make noise. Next one. Therefore, the sequence 1 by n is what? Bounded above sequence. The sequence 1 by n is bounded above sequence. And listen, m is called, the value m is called upper bound. M is called upper bound of the sequence. M is called upper bound of the sequence an. If it is bounded above, then the sequence has an upper bound. Sequence has an upper bound. M is called an upper bound. Now through the examples, upper bound is unique. Through the example, upper bound is unique? No. Here 1, 1.1, 1.2, all are upper bounds. All are upper bounds. Upper bounds for what sequence? 1 by n sequence. Now among all these upper bounds, which one is the least one and the least value? And the least value of upper bounds. Least value of upper bounds is 1. Therefore, 1 is called least upper bound. 1 is called least upper bound. Simple notation is LUB, or it is also called as supremum. Least upper bound or supremum. Least upper bound or supremum. This is the concept in upper bound. Bounded above sequence. Bounded above sequence means every value of the sequence must be less than or equal to some particular value. That value is called upper bound. And that upper bound is not unique. The sequence has many upper bounds. Among all those upper bounds, the least value is called LUB, least upper bound or supremum. Okay. And the next one is bounded below sequence. Similarly, you can construct so many examples for bounded above. Just to understand the concept, I am giving only simple example. Bounded below sequence. Bounded below sequence. A sequence AN is said to be bounded below. Sequence AN is said to be bounded below. Bounded below. If there exists a constant. If there exists a constant, some k, I will take k, such that every value of the sequence must be greater than or equal to k for all n. Every value of the sequence must be greater than or equal to k for all n. That is, a1 is greater than or equal to k, a2 is greater than or equal to k, and so on. And so on. Then k is called lower bound of the sequence. K is called lower bound of the sequence. AN. Now example. If I consider AN equal to some n square. AN equal to n square. What is the meaning? 1 square, 2 square, 3 square, and so on. Okay. So simply every value is greater than or equal to what? 1 square is greater than or equal to 2 square is greater than or equal to 3 square is greater than or equal to what value?
1.
1, exactly. Maybe 0 also, right? Right?
Yes.
So let me take
1,
1, 1, 1, and so on. Or 1 square is greater than or equal to 0.9, 2 square is greater than or equal to 0.9, and so on. Therefore, what is here? 1, 0.9, 0.8, or so many points are there, are all lower bounds. All are lower bounds. And 1 is this 1 is the greatest value, right? 1 is called greatest lower bound. 1 is called greatest lower bound or infimum. Now, say this is one example. Now, second example, let me take previous example. If I consider an equal to 1 by n, already we know that this is bounded above sequence. Is it bounded below? This is 1, 1 by 2, 1 by 3, and so on. Is 1 greater than or equal to 1 by 2 greater than or equal to 1 by 3 greater than or equal to, and so on. What is the value? Every value is greater than or equal to what in this sequence?
0.
Exactly. 0. Right? Or one can say 1 greater than or equal to -1, 1 by 2 greater than or equal to -1, right?
Yes, sir.
Right? Therefore, the sequence 1 by n is bounded above as well as
Bounded below.
bounded above as well as
Below.
bounded below. As well as bounded below. When a sequence is bounded above as well as bounded below both, that sequence is called bounded sequence. That sequence is called bounded sequence. Bounded sequence definition: a sequence an is bounded if it is bounded above and bounded below. Bounded above and bounded below. Meaning of this what? That is every value is bounded above m, and the bounded below means greater than or equal to k. This is true for all n. This is true for all n. This is called bounded sequence. Any doubts in this concept? Bounded? Right? See, one more example. If I consider an equal to -1 whole power n, -1 whole power n, right? These are the values. Now tell me -1 is less than or equal to 1 less than or equal to, and -1 greater than or equal to 1 greater than or equal to. What are the values? Is it possible?
Yes.
To find, yes. What is the first case? -1 less than or equal to
2.
Yeah, you can take some value 2. Here also 2, and this one
-2.
-2.
okay, -2.
-2.
Right? Therefore, the sequence is what? Bounded sequence, both bounded above and bounded below. Or one can write this is yeah, -1, correct? No, +1.
1, sir.
1. Okay. Or here I will write -1 or plus -1, correct? Okay. So I can write here clearly the sequence is, every term of the sequence is less than or equal to 1, correct? And greater than or equal to -1, right? Therefore, -1 whole power n is what? Bounded sequence. Is bounded sequence. Now I will give one more example. An is equal to -1 whole power n into n. So what are the values here? -1, +2, -3, 4, -5, and so on. Now tell me, take every value. Is it less than or equal to something or greater than or equal to something? Tell me, is it bounded above or bounded below or both?
-1 is less than equal to 1. 2 is less than equal to 1. Less than
It is unbounded.
It's not a bounded sequence, sir.
Not a bounded sequence, sure?
Yes, sir.
Yes, sir.
Right? Here, so you have to mention clearly. See, in intermediate, this MSET and the JEE mains, all exams are multiple choice. You can work out the problems, but you have to put the option, right? ABCD options. But in BTech, not like that. Okay, you have to write everything on the paper. If, for example, some limit value is given, limit of some function, find limit of some function. Don't put answer directly. You have to show, you have to prove that. Okay, it's not intermediate, it's BTech. So you have to elaborate everything on the paper. Okay. Now here, it is not possible. It is not possible to find the constants capital M and K, such that not possible. I have written an less than or equal to M or an greater than or equal to K. Therefore, this -1 whole to the power of n into n is not a bounded sequence. Not a bounded sequence. Okay, this is about boundedness of a sequence. Bounded above, bounded below, and bounded sequence, and some examples. Any doubts? If there is no doubt, will I continue another one? I will proceed to next one.
Proceed.
Yeah.
Yes, sir.
Next one is monotone sequence. Monotone sequence. Monotone sequence means a sequence AN, first case, a sequence AN is said to be monotonically increasing sequence. Monotonically increasing sequence. Monotonically increasing sequence if an nth term is always less than or equal to n plus 1th term for all n. Monotonically increasing sequence if nth term is always less than or equal to n plus 1th sequence. What is the example? Anybody? Nth term must be always less than its next term.
Set of integers.
Yeah, one
Set of
square.
Set of
N
natural.
natural
Yeah,
numbers.
all those are right. This is monotonically is, I will write m dot I means monotonically increasing sequence, right? Second one, the sequence an is said to be monotonically decreasing, is said to be monotonically decreasing if nth term is greater than or equal to n plus 1th term. It is true for all n. So example is what?
1 by 2 power n.
Okay, 1 by n square or 1 by n I can take. So 1 is greater than 1 by 2, 1 by 2 is greater than 1 by 3, and so on. Monotonically decreasing sequence. Now the definition, a sequence an is said to be monotone. An is said to be monotone if it is either monotonically increasing or monotonically decreasing, anyone, either monotonically increasing sequence or monotonically decreasing sequence, it is called monotone sequence. It is called monotone sequence. Now, can you tell bounded sequence is monotone? Yes? Bounded sequence is monotone?
No. No. Increase.
No, sir. Yes.
No? Hey, see the sequence?
Yes, sir.
It is decreasing.
What is this? Bounded below.
Below.
It is monotonically decreasing sequence, right?
Yes, sir.
Yes, sir.
And as well as bounded above as well as bounded below, right? Okay, so bounded sequences are monotone, either monotonically increasing or monotonically decreasing.
Decreasing.
Okay, I will stop here. In the next class, I will tell the concept of limit and convergent, divergent sequence and oscillating sequence. Okay.
Sir, can you show lower bound sequence, sir?
Lower
Bounded sequence.
lower bounded sequence. Yeah, this example, it is here. What is lower bound means? See, this is one sequence, an equal to n square, 1 square, 2 square, 3 square, and so on. So every value of the sequence must be greater than or equal to some value. So by observation, what we have, 1 square greater than or equal to 1, 2 square is also greater than or equal to 1, 3 square is also greater than or equal to 1. So this one is called lower bound of this sequence. One is called lower bound of the sequence. Similarly, again by observation, 1 square is greater than or equal to 0.9. Or one can take 0 also. 1 square greater than or equal to 0, 2 square is greater than or equal to 0. Like that, there is another lower bound exists here, 0.9. So there are so many lower bounds exist when a sequence is bounded below. When a sequence is bounded below, there are many lower bounds exist. This is for this example 1, 0.9, 0.8, 0.7, and so on. All these are lower bounds. Among all these lower bounds, which one is the greatest one? 1. That one is called greatest lower bound or infimum. One is called greatest lower bound or infimum. Is that clear?
Yes, sir.
So the
Any more
k
doubt?
value of lower bound, it doesn't exist in the sequence, sir. Like you
Yeah, exactly. See, remember, good doubt. Lower bounds, all the lower bounds not belongs to the given sequence, but the greatest lower bound definitely, maybe belongs to the given sequence. Good
Okay.
doubt.
Thank you.
Okay. Any more? Okay, shall I stop? All of you,
Sir.
put a
Yes.
separate notes for mathematics and write down these notes. I will share these notes in Google Classroom or in WhatsApp group. Okay.
Okay. Sir.
Yeah.
Okay,
Someone asking doubt. Come on.
Sir, does all the bounded sequence come under monotonic, sir?
Yeah, you conclude yourself.
Like in the example, the set of an into n, the
A
set is
N.
bounded between -1 and 1.
Which one? Which one? Which
An into
example?
n.
Which
The
example?
example an into n, sir. That is -1 power n into n. The third one,
Yeah.
which is seen on the screen.
Yes, it is not bounded sequence,
Uh,
no? This example,
so
na?
like if the outcomes come, sorry, second one, sir.
Second one, -1 whole power n.
Yeah. Yes, sir.
Yeah.
The outcomes are between -1 and 1, no, sir.
See. This is, what is this
So
set
it's a
finally? -1 comma 1, right?
Yes, sir.
-1 comma 1, right? So here, every term is less than or equal to 1. Agreed?
Yes, sir.
What is that? Increasing or decreasing, na? Here only two terms are there. So first term is less than second term, correct?
Yes, sir.
So monotonically increasing.
And again the next.
Ah.
But then it fluctuates between -1 and 1, no, sir. So how can we say
No.
it is either
Fluctuate.
increasing or?
Listen. Yeah, a good doubt. That is concept of limit. You told fluctuate means it is when I raise n from 1 to infinity. When I raise n from 1 to infinity,
Yes, sir.
it will oscillate between -1 and +1, right? But coming to
-1. Yes,
sequence,
sir.
it is a finite sequence. Even though it is taking infinite number of values, we are making it as a finite because repeated values are there. Right? But
Okay.
when we go for your topic, the next topic is that one only, oscillate sequence. Actually, this is oscillate sequence. But coming to monotonic increasing, it is true. Bounded sequence and monotonically increasing sequence.
So what about the third example?
Yeah?
Yes,
What
sir.
about
Thank you.
the third example, sir? It's -1 raised to n into n. What do we call it?
-1 raised to the n. It is a set, complete multi-set. When I raise n values, if n equal to 1, my
No, sir.
negative
The
1.
third example, -1 raised to n into n.
Yeah, this is what just example for sequence. It is not bounded sequence. It is not monotone sequence.
Okay, sir.
Just I am showing one example, which is not bounded sequence, which is not monotone sequence. The third
Okay,
example.
sir. Okay,
Okay?
sir.
Yeah.
Yes, sir.
Any more doubts? I will continue this fastness. The speed is okay?
Yes, sir.
Yes, sir.
Okay.
Yes,
Thank you.
sir.
Please
Yes, sir.
prepare notes for this one every day.
Yes, sir.
Since it is 1 hour class, I will take more. Okay, thank you.
Thank you, sir. Thank you, sir. Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Attendance, sir.
Sir, what reference we have to follow, sir?
Sir left the meeting.
Sir left.
He just left like this.
Yes.
Yeah.
Sir, both is
Do we have class at 2?
You guys
We have
understood
class
everything?
at 2 o'clock.
This is getting recorded.
Yeah.
No, this is getting recorded. Okay, fine.
Leave the class.
Yeah, it's getting recorded.
Actually, fine. What was your doubt, basically?
I doubt.
Yeah, the limit for the doubt. I didn't understand.
Okay.
Share it with
It was
me,
the
no,
bound.
afterwards.
Okay. Yeah. I'll message you.
Should we leave? Yeah, it's done now.
Hello. Hello, Bhanu Sumant. Am I audible? Hello, Basit. Hello, hello, hello. Hello.